late night coding sessions, and a little gaming on the side, this guide is for you. Now, let's talk about the basic laptop requirements for machine learning. Before choosing a laptop for machine learning or AI in college, it's important to understand one thing. Not every laptop can handle ML workloads. So when you are learning machine learning, you are not just browsing the internet or writing simple documents. You will be working with Python, Jupyter notebooks, large datasets, and frameworks like TensorFlow or PyTorch. All of this require a laptop with the right hardware. First, let's talk about processor or the CPU. This is the brain of the laptop and it handles most of the work in machine learning, especially tasks like data pre-processing, feature engineering, and running algorithms such as linear regression or random forest. Ideally, your laptop should have at least an Intel i5 or an AMD Ryzen 8 series processors, something like an Intel i5 12450H or a Ryzen 5 6600H with 6 to 8 cores and boost speeds of around 4 GHz or higher. This ensures that your laptop can process datasets quickly. Next is RAM, which is extremely important for machine learning. When you are training models or analyzing data, the dataset is often loaded into the memory. If your laptop only has 8 GB of RAM, things can slow down very quickly. That's why the recommended minimum is 16 GB of DDR4 or DDR5 RAM, which allows you to run Jupyter Notebook, VS Code, Python environments, and machine learning browser tabs simultaneously without crashing your system. Storage is another key component. Machine learning datasets and model files can easily take up a lot of space. A laptop should ideally include at least 512 GB of NVMe SSD. NVMe SSDs are much faster than traditional hard drives, which means faster dataset loading, quicker program execution, and a smoother system performance. Finally, if you want to explore deep learning, computer vision, and neural networks, having a dedicated GPU becomes very useful. A laptop with an NVIDIA RTX 3050 GPU with up to 4 to 6 GB of VRAM allows frameworks like PyTorch and TensorFlow to use CUDA acceleration, which can make model training several times faster than using only CPU. When a laptop includes these specifications, a strong CPU, 16 GB of RAM, fast SSD, and RTX 3050 GPU, it becomes capable of handling real machine learning workloads throughout your college journey. Now, here comes the big question. Should you buy a MacBook or a Windows laptop? If you have the budget, honestly, you won't find many laptops as premium and efficient as a MacBook Air M4 15-inch. It comes with a powerful Apple M4 chip, 16 GB of unified memory, and 512 GB of SSD, giving you insane battery life, smooth performance, and a super premium build. But here comes the important part. MacBooks don't use NVIDIA GPUs. Instead, Apple uses its own Metal framework for GPU acceleration. While most machine learning libraries are built around NVIDIA CUDA, which is the industry standard for deep learning. So while a MacBook is powerful, you might face limitations when working with TensorFlow, PyTorch, GPU training, or advanced deep learning projects. Now think of it like this. When you first learn driving, you don't start with a luxury car. You learn on something simple, understand the basics, make mistakes, and then upgrade. It is the same with machine learning. If you are just starting college, I would suggest going with a Windows laptop with an RTX GPU, like an RTX 3050. It gives you CUDA support, better compatibility, and more flexibility for ML projects. Later, when you understand everything better, then upgrading to a MacBook actually makes sense. So for now, learn on Windows, master ML, then upgrade smart. And I will suggest you 5 Windows laptops that will be equally as powerful as a MacBook and fits in your budget. The Acer Nitro V is one of those laptops that quietly delivers everything a machine learning student actually needs. At the heart of the system is an AMD Ryzen 5 6600H processor, a high-performance laptop CPU designed for heavy workloads. It comes with 6 cores and a boost speed of up to around 4.5 GHz, which means that it can process large datasets and run parallel computations efficiently. In machine learning, CPU power is used heavily during data pre-processing. Before you train any model, you usually spend hours cleaning datasets with pandas, transforming features, running NumPy computations, and preparing training pipelines. All of these tasks rely heavily on CPU cores. The Ryzen 5 6600H handles them smoothly. But the real magic for AI students comes from the NVIDIA RTX 3050 GPU with 6 GB of VRAM. This is where deep learning becomes actually possible. Frameworks like TensorFlow, PyTorch, and CUDA are optimized for NVIDIA GPUs. Instead of training neural networks on the CPU, the GPU can handle thousands of matrix operations simultaneously. For example, training a convolutional neural net or CNN for image classification might take 4 to 5 hours on CPU, but it will take only 30 to 40 minutes on the GPU. That's the difference that completely changes your workflow as a student. The Nitro V also includes 16 GB of DDR5 RAM, which is the sweet spot for ML beginners. The machine learning tools also consume memory quickly. Imagine running Jupyter Notebook, VS Code, Chrome with 20 tabs, and Python virtual environments. Without enough RAM, your laptop will slow down and crash. With 16 GB of DDR5 RAM, multitasking becomes smooth. Next is storage. The laptop uses a 512 GB of PCIe Gen 4 NVMe SSD. This matters because ML datasets can become very large very quickly. A single dataset for computer vision or neural language processing can occupy tens of gigabits. NVMe SSD speed ensures that datasets load quickly, models are saved faster, and notebooks start instantly. Another underrated feature is the 15.6-inch Full HD IPS display with 165Hz refresh rate. While refresh rate is mostly marketed for gaming, it actually helps during long coding sessions. The screen feels smoother when scrolling through large datasets or reading code. Finally, the laptop supports Wi-Fi 6 connectivity, which is useful when downloading large datasets from Kaggle or GitHub repositories. So when you combine Ryzen 5 performance, RTX 3050 GPU acceleration, 16 GB of DDR5 RAM, and NVMe SSD storage, you get a laptop capable of running real AI workloads locally. For a student who wants to build projects like image classification systems, object detection models, ML prediction apps, AI chatbots, the Acer Nitro V becomes more than just a laptop. It becomes your first AI workstation. The Lenovo LOQ is built for long ML training sessions. At its core is the Intel i5 12450 HX processor. Unlike typical laptop CPUs, the HX series processors are designed with desktop-class power and higher thermal levels. This means that they can sustain heavy workloads for longer periods without slowing down. For machine learning students, this matters during feature engineering, running sklearn pipelines, hyperparameter tuning, and compiling ML libraries. Many of these tasks rely on CPU threads running simultaneously. The i5 12450HX can deliver and handle multiple operations at once, reducing the time needed to prepare training datasets. Just like Nitro V, the Lenovo LOQ also includes the NVIDIA RTX 3050 GPU with 6 GB of VRAM. This enables GPU accelerated deep learning. This GPU allows students to experiment with projects such as yellow object detection, GAN image generation, CNN image classifiers, and transformer models for neural language processing. Deep learning relies heavily on matrix multiplication, which GPUs can perform 1000 times faster than CPUs. But the real advantage of the LOQ isn't just raw performance, it's thermal stability. Training machine learning models can push your hardware to 100% usage for hours. If a laptop overheats, it starts throttling performance. Lenovo designed the LOQ series with strong cooling systems so that the CPU and the GPU can maintain performance during long training runs. The laptop also comes with 16 GB of RAM, which allows large datasets and ML environments to run simultaneously. For example, a typical ML workflow might include loading datasets into memory, running pre-processing scripts, training models, visualizing results with Matplotlib or Seaborn. Without enough RAM, these steps become painfully slow. The 512 GB of SSD storage also ensures fast read and write speeds when working with datasets and saved model checkpoints. Another important factor is the 144Hz Full HD display, which gives plenty of screen space for coding, debugging, and data visualization. For students who plan to spend hours writing Python code, experimenting with algorithms, and run models repeatedly, the Lenovo LOQ becomes a very reliable AI development machine. It's the kind of laptop that doesn't just run ML models, it runs them consistently for hours without slowing down. The HP Victus comes with a powerful CPU for heavy ML workloads. It is powered by an AMD Ryzen 7 7445HS processor, which is incredibly powerful. It is built with 8 high-performance cores and a strong multi-threading capability, which means that it can process large datasets much faster than entry-level CPUs. In machine learning, this is extremely important because before you even train a model, you spend hours of time on data pre-processing. Tasks like cleaning datasets with pandas, performing feature engineering, scaling numerical features, running cross-validation are all the CPU-heavy operations that you will perform. When working with large datasets, these operations can take a lot of time on weaker processors. But with a powerful CPU like the Ryzen 7, the laptop can process multiple tasks in parallel, significantly reducing computation time. Then comes the GPU. Just like other laptops on this list, the HP Victus includes the NVIDIA RTX 3050 GPU with 6 GB of VRAM. This is extremely important for anyone who is planning to explore deep learning or computer vision. Frameworks like PyTorch and TensorFlow are optimized for CUDA-enabled GPUs. Instead of performing neural network computation sequentially like a CPU, the GPU can run thousands of computations simultaneously. For example, when training a convolutional neural network for image classification, the GPU handles matrix multiplication and convolutional operation and gradient updates much faster. This allows students to experiment with projects such as face recognition systems, image classification models, object detection algorithms, and neural style transfer without completely relying on cloud GPUs. Another advantage of this laptop is the 16 GB of DDR5 RAM, which ensures smooth multitasking during ML workflows. A typical AI student often has multiple programs open at once: Jupyter Notebook running experiments, VS Code for writing scripts, Chrome tabs for research papers, TensorBoard for visualizing training progress. With enough RAM, the system can handle these tasks simultaneously without slowing down. The ASUS TUF Gaming laptop is built for long AI experiments. The TUF series is known for its durable build quality and strong cooling system, making it ideal for heavy workloads like gaming, video rendering, and of course AI model training. Inside the laptop is an Intel i5 210H processor, which is the 14th generation lineup. This is the newer processor which brings improvement in both performance and efficiency. It handles demanding tasks such as compiling Python libraries, running Docker containers, executing data pipelines, and performing statistical analysis. These are the common operations in machine learning development. Alongside the CPU is an NVIDIA RTX 3050 GPU with 6 GB of VRAM. This again unlocks GPU accelerated deep learning. Students working on AI projects often experiment with neural networks that require thousands of training iterations. Without a dedicated GPU, this process can become extremely slow. But with CUDA-enabled GPUs like an RTX 3050, this laptop can accelerate operations such as matrix multiplication, convolutional operations, backpropagation during neural network training. This allows students to train models locally rather than depending entirely on cloud services. Another standout feature is the 16-inch Full HD Plus display with 144Hz refresh rate. For programmers and data scientists, screen size really matters a lot. When working with datasets, code editors, and visualization tools simultaneously, this extra space improves productivity significantly. Students can comfortably run VS Code on one side, Jupyter Notebook on the other, terminal window in the background without feeling cramped. This laptop comes with 16 GB of RAM, which provides enough memory to handle medium-sized datasets and ML experiments. Many machine learning libraries store data in memory while running algorithms, so having sufficient RAM ensures smooth performance. The 512 GB of NVMe SSD ensures quick dataset loading and fast boot times. Finally, the TUF series is known for its military-grade durability and certification, meaning the laptop is built to withstand daily wear and tear. For college students who carry their laptops between classes, hostels, and labs, durability becomes an underrated but important feature. So the ASUS TUF is not just powerful, it is designed to handle long AI workloads without breaking a sweat. The ASUS Vivobook 16X laptop packs an AI power in a lightweight design. Now not every machine learning student wants a bulky gaming laptop. Some prefer something lighter, easier to carry around the campus, and more professional looking. That's where the ASUS Vivobook 16X becomes an interesting option. At a first glance, it looks like a sleek productivity laptop rather than a gaming machine, but inside it still packs enough hardware to run serious machine learning workloads. The laptop is powered by an Intel i5 13420H processor, a high-performance H-series CPU designed for demanding tasks like programming, data analysis, and content creation. In machine learning, this CPU handles tasks such as data pre-processing, dataset transformation, statistical computation, and running classical ML algorithms like random forest or SVM. These operations require strong CPU performance, especially when working with structured datasets. But the most surprising feature of the Vivobook 16X is that it still includes an NVIDIA RTX 3050 GPU. This means that despite its slim design, the laptop still supports GPU-accelerated deep learning. Students can run experiments involving convolutional neural networks, transfer learning, computer vision models, PyTorch deep learning frameworks without relying entirely on online GPUs. Another advantage is the 16-inch Full HD Plus display with a 16:10 aspect ratio. This is slightly taller screen, providing more vertical space, which is extremely useful when writing code or reading long datasets. When working inside programming environments like Jupyter Notebook or VS Code, the extra screen space means you can see a lot more lines of code at once. The laptop also includes a 16 GB of RAM, ensuring that multiple ML tools and development environments can run smoothly. At just 1.8 kg, this is significantly lighter than most gaming laptops. For students who commute daily or carry their laptops to lectures and labs, this portability makes a huge difference. The 512 GB of NVMe SSD provides a fast storage for datasets, models, and development tools. So while the Vivobook may not look like a typical AI machine, it is a combination of powerful CPU, RTX GPU, lightweight design, and a large display, making it a great option for students who want machine learning performance without carrying a heavy gaming laptop